People sometimes talk about energy systems. So what are they and why are they important? The Intergovernmental Panel on Climate Change, or IPCC, defines an energy system as all components related to the production, conversion, delivery and use of energy. An energy system may therefore contain a number of different elements, but it always has boundaries. These boundaries are not fixed and you can choose where you draw them. But once drawn, you need to be consistent with how you use them. A system can also have energy or mass go into and come out of it. So what's inside the boundary is not necessarily isolated from the outside. The flow of mass and energy is governed by the laws of conservation. The law of conservation of mass says that mass that enters a boundary must either leave the boundary or accumulate within the boundary. Similarly, the law of conservation of energy, which is also the first law of thermodynamics, says that within the system boundary, energy can change form from one form to another, but the total amount of energy in that boundary remains constant. The key to understanding the law of conservation of energy is remembering that energy has many different forms. If you look at a system and think that you have lost energy somewhere, what it really means is that the energy has changed into a form that you haven't thought of yet. Different forms of energy include kinetic, electrical, potential, and thermal, where kinetic energy is the energy something has due to its movement, electrical energy is due to the movement of electrons, potential energy is due to its position or chemistry, and thermal energy is due to temperature. You can see energy changing forms when you drop a tennis ball. When you hold the ball off the ground, it has potential energy. When you drop it, the tennis ball moves and the potential energy changes into kinetic energy. Once it has stopped moving and is lying still on the ground, it no longer has any potential or kinetic energy left, and so this looks like energy has been lost. But actually the energy just changed form to become kinetic energy in the form of sound and a little bit of thermal energy. So this illustration begs the question, are all forms of energy equally useful? This question relates to how easily we can transform energy from one form to another in order to do work. So when I drop my tennis ball, I could probably do something useful with the kinetic energy. But can I do anything with the sound and heat that gets produced? No, probably not. So this leads us to the idea that not all forms of energy are equal. There are some forms that are easier to use than others. With electricity or electrical energy, we can utilize almost all of the energy. So if I have 100 kilowatt hours of electricity, I can do almost anything with that, and in most cases at very high efficiencies. But it depends on what you want and how you do it. An incandescent electric light bulb transforms only about 2% of the electric energy into light, which is terrible efficiency given you wanted light in the first place. It's probably also the reason for the drive to develop lighting like fluorescent tubes and light-emitting diodes, or LEDs, which turn much more of the electrical energy into light. The remaining 98% of the electrical energy is transformed into heat. Because we don't want the heat, we often say this energy is lost, but what we really mean is that it is lost as heat. The bad news is that conversions are usually only efficient in one direction. For example, you would never try to take the light from your fluorescent tube and turn it back into electricity through a solar panel, because every time you convert it from one form to another, you lose part of what's useful and easy to use. So, energy systems are all around you. And it's important to recognize that when you are dealing with energy problems, you are dealing with energy transformations within a system. You get to draw the boundaries of the system wherever you want, but you need to make sure that you use the boundaries consistently. And whether it's mass or energy, you need to end up with the same amount that you started with. Now that we have talked about energy systems and the laws of conservation, you will be better able to make sense of what you hear and see and understand about the limits of energy systems.